In this video, we're going to learn how to solve systems of linear equations. Now, what is a system of equations? Well, it's going to be a set of one or more equations that share the same answer or answers. Now, a system of two equations will have two variables. Let's take a look at an example. I'm going to go ahead and tell you that 4, 1 is a solution to the system x plus y equals 5 and 2x minus 4y equals 4. And I'm going to show you why. What I'm going to do is I'm going to check the solution in both equations. So I'm going to start by checking it in that first equation. Where the x is, I'll put in a 4. Where the y is, I'll put in a 1. And I have 4 plus 1 equals 5. And I put a little question mark over the equal sign to say that that's what I'm checking. Now 4 plus 1 does equal 5. So 5 equals 5 is true. I changed my question mark to a check mark. It worked in the first equation. However, in order to be a solution to the system, it has to work for both equations. So we're going to also show that it works in the second equation. So I'll again replace the x with 4 and the y with 1. Now that gives me 2 times 4 minus 4 times 1, or 8 minus 4, which of course is 4. So 4 equals 4. The two sides do match. 4, 1 is a solution to this system. Now, what if I don't give you the answer though? How do you find it yourself? Well, one method you can use is called substitution. To do that, you will solve for one variable in one equation, then you'll replace that variable in the other equation. Once you have solved for the value of the second variable, you can then back solve for the first value of the first variable. Then you're going to write your final answer as an ordered pair. Now, don't worry if that sounds complicated. We're going to walk through an example. So let's say we have y equals 2x plus 1 and 5x minus 2y equals 1. Well, this system of equations is perfect for substitution because our first equation is already solved for y. As long as you have one variable by itself, it is so easy to use substitution. So we are going to substitute that y equation into the second equation. So everywhere there is a y in the second equation, I'm going to replace with 2x plus 1. So that looks like 5x minus 2, and then I put parentheses around 2x plus 1 equals 1. Now I can solve for x in what I have left. Now in order to do that, I'm going to start by distributing my negative 2. Then I'm going to combine my like terms, which would be 5x minus 4x gives me x. Then all I have to do is add 2 over. So now I know my x value equals 3, but remember, we need both an x and a y value. So I'm going to back solve for y by plugging in x equals 3 to one of my equations. Now I can pick either equation and get the same answer because we know that we'll have the same answer because it's the solution to the system. However, I do like the first one because y is already by itself. So I'll plug x equals 3 into 2x plus 1. So that becomes 2 times 3 plus 1, which is 6 plus 1 or 7. So now I can write my answer as an ordered pair. Since x equals 3 and y equals 7, that gives me the point 3, 7. Now that's not the only way to solve a system of equations though. Another option is solving by elimination. To solve by elimination, you're going to multiply each equation by a constant so that the coefficients of one of the variables match, but they'll have opposite signs. That way, you can add the equations together and the variable is eliminated. That only leaves you with one variable left in the resulting equation, so you can solve for the value of that remaining variable. Then you can back solve like we did in the last version for the first value and write our answer as an ordered pair. Now, this next example is really great for elimination because all the x's and y's are on one side and all the constants are on the other. This is called standard form of a linear equation, and it makes it really easy to work with for elimination. Now, in this case, I am going to eliminate x because I can see that my x's are almost the same coefficient. One is 3 and one is 1. So in order to make them the same coefficient but opposite signs, I'm going to multiply through the second equation by negative 3. Because then I'll have negative 3x minus 15y equals negative 27. So now that matches the 3x from the first equation, but again, opposite signs is the key part. So now I've replaced my second equation with my new version. I can add them together. 3x and negative 3x cancel when I do that. 2y minus 15y is negative 13y, and 1 plus negative 27 is negative 26. Now to solve for y, I just need to divide both sides by negative 13. That gives me y equals 2. Now that I know my y, I can use it to back solve for x. So I can plug it into either equation, but I'm going to choose to plug into the first one because it's first. So that gives me 3x plus 2 times 2 equals 1, or 3x plus 4 equals 1. So now I can subtract 4 from both sides and get that 3x equals negative 3. Dividing by 3 gives me x equals negative 1. Now I know that x equals negative 1 and y equals 2. I can write it as my ordered pair, negative 1, 2. And that's how you solve systems of linear equations.